All right, here are the answers to the coordinate geometry review sheet. Very important topic. Getting into just some simple things right off the bat. The steepness of JK is 3 over 4. If it's going to be perpendicular to PQ, then PQ's slope has to be the negative reciprocal. Some teachers call it opposite reciprocal. It would be negative 4 over 3. All right, next up. Find the slope and length of AB. Well, at least for my students, I like to show how slope can lead you to the length. The slope formula is the change in the y over the change in the x. You can figure out the slope also by looking at the picture, but here they're giving us the coordinates. So following the formula, the slope would be 8, take away negative 6 over negative 1, take away 4. So I'm getting a subtracting of a negative there, which is the same thing as adding a positive, which is bringing me to 14 over negative 5. So the slope would be down 14 over 5. Now I can quickly turn that slope into a length by just using a version of the Pythagorean Theorem. So I'm taking the 14, squaring it, and adding it to the 5 squared. Remember, you don't have to include the negative sign there because the negative would be squared away, leaving with a positive answer anyway. So 14 squared plus 5 squared bring it to 222, and that would be the length, the square root of 221. That would be the exact length. If you typed it into the calculator, you could get a rounded answer of about 14.9 spaces long. Okay, that's question number 2. I can't say enough about it, how important that is. It's one of the building blocks for a lot of the things that we do. Is finding the slope and finding the length. Question number 3, 4, and 5 are all connected to each other. All of them involve equations of lines, and sometimes you'll be asked to look at perpendicular situations, sometimes with parallel. So it all depends on the style of question. This one we're looking for an equation of a line that passes through this point. There's an x and there's a y, and it's perpendicular to this equation here. Well, the slope that we've got is negative a half. The slope that we need is perpendicular, which means it would have to be the negative reciprocal, which would be positive 2 over 1, or just 2. So I know the equation has to have a slope of 2, so it has to be down to either choice 3 or choice 2. Only one of them will go through this point. What I can use is y equals mx plus b to decide which of the two equations is correct. We know that y is 2. We just found out that the slope is 2, and the x coordinate is 4. So solving this little equation here tells me very quickly that the y-intercept should be negative 6. Question number 4, talking about a parallel line. Well, first of all, I have to find the slope of this line. To do that, I'm going to get y by itself, so divide both sides by 2. And I could recognize that the slope that I've got currently is 3 over 2. The slope that I need Well, I need something that's parallel, so it'll be exactly the same slope. So we're looking for a slope that's 3 over 2, so it couldn't be this one. This one here has a slope that's negative 3/2, so it's not that one. This one has a slope that's 2/3, so it's not that one. It must be choice 4. For question number 5, alright, it says perpendicular. Well, the first things up is to figure out what the slope of this equation is. You could very quickly begin by subtracting 4x from both sides. Once you've done that, you can continue to solve by dividing both sides by -6. Which gives you a very unusual looking y-intercept, but the slope is -4 over 6, or 2/3 x. So the slope that we've got is 2/3. The slope that we need must be -3 over 2. By the looks of some of these equations, I can cancel it down to just those two. We're looking for the one that goes through the point 6, 9. So 6 would be my x and y would be my 9. I could take those numbers, plug them. This is one way to work the question out. I could take those numbers and plug them into the formula. If y is 9 and x is 6, does that make that first equation true? I'd get 9 minus 9, which is 0, and I'd get -3/2 times 0, which would also be 0. So this one does work, which leads me to believe that this one will not work. So choice 1 is the answer. Alright, on to a very important question, doing a coordinate geometry proof. Now, a lot of students will see the word proof, and they'll start thinking about statements and reasons, and that's not right. Okay, so when it comes down to doing a question like this, a proof like this, the proof is made up of calculations and a sentence. You must have both parts to get full credit. So they're asking me to prove that it's a parallelogram and it's not a rhombus. Well, to prove that it's a parallelogram, I'm going to have to look at the slope. To prove that it's a rhombus, I'm going to have to look at the lengths. One very convenient way to do that is to make a little table with all of the sides listed, AB, BC, CD, and DA. And on this table you can record the slope. You could also include the length. So AB is a negative slope. I know it's negative because it is going down from left to right. The letter N has a negative slope in it. It's negative if it's falling from left to right. So AB is falling by how much? Down 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 6 over 9. If I follow the same sort of pattern here for DC, I'd see that CD or DC is also down 6 over 9. While the other sides, AD and BC, also have a negative slope. The slope of BC is down 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3. So BC is a down 9 over 3. DA is also down 9 over 3. So it must be a parallelogram because the opposite sides have equal slopes. I don't even have to reduce them to notice it. I could reduce those slopes and probably should. just because I may be trying to figure out if they are negative reciprocals anywhere. But if I did reduce them, I'm going to be getting negative 2/3, or negative 3/1, negative 2/3, and negative 3/1. So the opposite sides have equal slopes. And since opposite sides have equal slopes, then I know that opposite sides must be parallel. And I have to write all that down below. So ABCD is a parallelogram. The reason is because opposite sides have equal slopes. Therefore, opposite sides are parallel. The last part of the question says to prove that it's not a rhombus. To prove that it's not a rhombus, I'm going to have to prove that the sides do not have the same length. And to do that, I'm going to need to use the Pythagorean Theorem, the distance formula, or this very slick formula trick that I used on the first page. So I could take the square root of these numbers squared added together. So 6 squared plus 9 squared square rooted. And do the same thing for each and every one of these, ignoring the negatives, because the negatives when squared will become positive anyway. So after doing this, I'll have the lengths calculated out, and we'll notice that not all the lengths are the same. So 2 of the sides came out to be radical 117, and 2 of the sides came out to be radical 90. My work's not done. I need to actually write a sentence explaining what I've figured out. So ABCD is not a rhombus. The reason why I know this is because not all sides are equal in length. Okay, continuing on. So they're asking in 7 to prove or to show that this triangle is isosceles. To do that, I'm going to figure out the length of AB and AC, because those look to be the ones that might be the same length. So once again, I can use the slope to help me get the distances. We'll begin with the slope of AB is rising 1, 2, 3, 4 over 2, 3, 4, 5, 6, 7. So the slope is up 4 over 7, so that means that the distance can be figured out by doing the square root of 4 squared plus 7 squared. Never use the reduced slope, the numbers in the reduced slope in this calculation, or it'll be wrong every single time. So I get the square root of 65 for that length. For AC, it's a different slope. Well, that's okay. It's down 1, 2, 3, 4, 5, 6, 7, 8, and over 1. So down 8 over 1. I can take those numbers and use those numbers to help me figure out the length. So the length would be the square root of 8 squared plus 1 squared, which, surprise, surprise, comes out to be radical 65 again. So I have to finish up these calculations with a sentence explaining what I've just shown. Triangle ABC is isosceles because it has two equal sides. And you could even go on and say that AB is the same as AC. Next question up. Find the length of the altitude drawn from A to B, C. Okay, so I need to know the altitude, the length of the altitude in this triangle. Well, to do that, first of all, I have to figure out the slope of BC. Because my base of my triangle will be side BC as my base, and my altitude must be perpendicular to it. So I'm going to figure out the slope of BC, first of all. It's rising up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up 12 over 1, 2, 3, 4, 5, 6. So the slope of BC is up 12 over 6, which is the same as 2 over 1. And if my base has a slope that's 2 over 1, my altitude must have a slope that's the negative reciprocal, which would be negative 1/2. So the slope, looks like I wrote the word mult, the slope of the altitude must be negative 1/2. And you might have been able to get that visually by looking at the picture. So starting at A, going down 1 over 2, down 1 over 2, would get you a decent picture of what the altitude looks like. And it does look perpendicular to the base. So all of our work seems to be correct. They want to know the length of the altitude. Well, I'll call this point point D. So the length of AD can be figured out by calculating the slope first. So the overall slope is down 2 over 4. So the length of AD would be the square root of 2 squared plus 4 squared, which would be radical 20. Let me just see what they asked me. If they asked me to round it. Nope, it just says to find the length, and that's the answer. Question C. Using the results, find to the nearest degree the measure of the base angle of this triangle. All right, well, I just, backtracking to this, I found out that this was worth radical 20, and I'm asked to find how large the base angle might be. Well, just concentrating on just 1/2 of the picture, I do have a right triangle here, so I can use trigonometry to figure out the missing angle. And to do that, I'm going to need to know 2 of the sides in this triangle. I know one of the sides is radical 20. I also know the length of AB was radical 65. I can take those 2 measurements and use SOHCAHTOA with those. The radical 20 is the opposite side. The radical 65 is the hypotenuse. So if I want to figure out what angle A is worth, I can use SOHCAHTOA. Look at that, it's the very first choice. That's the only one that has the O and the H in it. So S would be for sine, so the sine of the angle equals the opposite side, radical 20, over radical 65. I would type that into the calculator by pressing the second button on the calculator to bring up the inverse command on the calculator, and then type in radical 20 divided by radical 65. Which brings me to the conclusion that x is about 33.7 degrees. Looks right in the picture too. It says round to the nearest degree. So it's a good idea that I double check what they wanted. 34 degrees would be the answer. And then, let's see, question D. Determine and state the coordinates of point D such that ABDC would be a parallelogram. Wow, this picture is getting very messy as I go through this, even though I'm being very organized. So this last question is asking where would point D have to fall so that this whole shape becomes a parallelogram. Well, I know the slope here is up 4 over 7. So the opposite side would also have to have a slope that's up 4 over 7. So 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7. So the true point, the point D that they were looking for would be right there. I can connect the points to make the shape, and it certainly does look like A, B, C, A, B, D, C is forming a parallelogram. They asked me to prove it's a parallelogram. All I would have to provide with them, or to them, would be the slope here and the slope here, showing that these slopes are equal. All right, on this last question, proving that it is a rhombus and then proving that it's not a square. Well, let me take the shortest route possible on this. To prove that it's a rhombus, I just need lengths. I could figure out the slopes of all the sides. So the slope of AB is equal to up 4 over 5. The slope of BC is down 4 over 5. And if I notice, I'm getting the same slope here, down 4 over 5, and the same slope here, up 4 over 5. I know that the opposite sides have the same slope, but that does not prove that this is a rhombus. It just proves it's a parallelogram. But what I'm noticing with all the work here is that it's the same numbers showing up over and over again. So all sides have the same length. All sides are using the same numbers in their slope, which would be square root of 4 squared plus 5 squared, or 25 plus 16, which would be radical 41. Therefore, it is a rhombus. Therefore, ABCD is a rhombus. Proving it's not a square, well, I've got all the information I need to do that right at the very top. These slopes are opposites of each other, but they are not negative reciprocals. So it's not a square because there are no negative reciprocal slopes. There aren't any negative reciprocal slopes. So there are none. There are no. There are none. So there are no right angles. So I can go on to conclude that ABCD is not a square. All right, have a nice day. Hope that was helpful for you.